Dear children, in this video I'll explain you about thermal expansion. This is the fourth video of chapter heat. Already in the first, second, third video I have explained many things about heat, how heat is produced, how heat is transferred, and which body is hot body and which is cold body, and here about difference between heat and temperature, the difference between evaporation and vaporization, how evaporation occurs, how vaporization occurs, then the factors affecting the evaporation and the change of state, what are the effects of heat. So many things I have explained. Already 3 videos I have completed. In this video I'll explain you about thermal expansion. What do you mean by thermal expansion? Thermal expansion means, thermal means what? Heat. And expansion means when heat is supplied or heat is given to a body, it will expand. That is called thermal expansion. So by giving heat, when a body will expand, that is thermal expansion. So there are 3 types of thermal expansion. One is linear thermal expansion, superficial thermal expansion, and cubical thermal expansion. One by one I will explain you. First, your like linear thermal expansion. First I am writing you thermal expansion. Thermal expansion. It is divided into 3 parts. First is your linear thermal expansion, superficial, then your cubical thermal expansion. Here first is your linear thermal expansion, superficial thermal expansion, cubical thermal expansion. So thermal expansion are 3 types. One by one I am explaining you. First I will explain you about linear thermal expansion. Linear thermal expansion. In linear thermal expansion, it refers to increase in length or, for example, we can say it refers to linear thermal expansion refers to increase in length only, no area, no volume, only in length. So example we can give a metal rod. So it occurs, where it occurs? It occurs only in solid. It occurs only in solid. Why it occurs only in solid? Because liquid and gas have no definite length or shape or size. That's why it occurs only in solid. So linear means the length. So the refers to increase in length, the linear thermal expansion, and it occurs only in your solid, no liquids, no gas. Example, suppose a metal rod. There will be, if a metal rod will heat, it will increase in length, no area, no volume. So it refers to your increase in length and it occurs only in solid. Now on what factors it depends? So this linear thermal expansion, it depends on the length of the rod. So length of the rod means, Suppose two rod you take, this is one rod and this is another rod. Two rod. Suppose two metal rod made up of same metal and it will give same amount of heat. So where the expansion will be more? This one, the second one, expansion will be more because more the length, more the expansion. So it depends upon the length of the rod. If you are giving same amount of heat and both the rod made up of same metal, here the length will expand more where the length will more. So second one length is more as compared to first one. This one length is more. Suppose this second one, this first one. So the expansion of the second one will be more than the first one because due to more length. More the length, more the expansion. Understood? Your third factors affecting your temperature. Suppose this metal rod, this is one metal rod and this is another metal rod, both have same length. Both have same length. Both metal rod 1, metal rod 2, both have the same length. Both have made up of same metal, but we are giving different temperature. So suppose in metal rod 2 we are giving more heat. So where the expansion will be more the temperature, more the expansion. So definitely the metal rod 2 will expand more than the metal rod 1. So more the temperature, more the expansion. Another factors affecting is your nature of the rod. Nature of the rod. Suppose this is made up of aluminum, first one, and this is made up of copper, second one. So both the metals having same length and we are giving same amount of heat, but the metal is different in both the cases. This first rod is made up of aluminum and second rod is made up of copper. So where the expansion will be more, aluminum will expand more. So metal rod will expand more because coefficient of linear expansion of aluminum is more than copper. That's why aluminum expand more. So metal rod 1 will expand more as compared to metal rod 2. So understood what are the factors or depends. The linear thermal expansion depends on the length of the rod, temperature and nature of the rod. Clear? Understood? Suppose mathematically I will explain this one, how mathematically will represent this one. Suppose L1 let L1 be the length at T degrees Celsius. At 0 degrees Celsius. 0 degrees Celsius, and L2 be the length at T degree Celsius. So now initial length is L1. After giving temperature T degree Celsius, the length is L2. So increase in length is equal to L2 minus L1. So L2 minus L1 is the increase in length. That depends upon what? The original length of the rod, temperature, the nature. Then here to express it in means equally we have to explain, means this increase in length equal to whom? We have to use a constant, that is linear coefficient of linear thermal expansion. So we can write increase in length as original length L1 into the coefficient of linear expansion alpha when temperature is T. So increase in length is equal to L1 alpha T, where alpha L1 is the original length, T is the temperature. What temperature we are giving, then your alpha is the coefficient of linear expansion, the constant we are using to equalize with the increase in length. So alpha is equal to coefficient of linear expansion. Coefficient of linear expansion.